So now we're going to talk about how the blockchain technology works. And we'll start with Bitcoin, then we'll move on to some other architectures. The question here is, what is the hash? So hashes are the foundation of blockchain. And the formal definition of a hash is any function that can be used to map data of an arbitrary size to data of a fixed size. And the value returned is known as hashes. So it's going to seem a little wonky, but it'll all make sense by the time we're done. So simply put, a hash, it's a function that takes in any data of any size and returns output with a specific size. The output is known as a hash, right? We just covered that. So as an example, if we had a hash function that said, no matter what data you gave me as an input, I was going to convert that to a 3-digit number, right? Then regardless of which of these things here on the right, this long string of characters, this medium-sized one, or the single character, no matter what you gave me as an input, I'm going to give you a 3-digit number. And since it's a function, like a math function, every time you put in the letter A, it's going to give you 792, right? Every time you put in the letter A, D, F, J, K, A, and the A is capitalized, every time you do that, it's going to give you the number 126. Because it's taking this input, it's running it through an equation, so to speak, and always giving the same answer. So just like every time you put in 2 plus 2 equals, you're going to get 4, right? And so every time you put in A, D, F, J, K, A, where the first A is capitalized, in this particular hash function, you get 126, right? Now, here's just another example. If you had a hash function that said, no matter what data you're going to give me as an input, I'll give you a 5-digit output. And it doesn't matter whether that data input is an image file, a movie, characters, graphics. It doesn't matter what the input is. If it can be expressed digitally, it's going to give you a 5-character output. Now, the hash function that's used in Bitcoin is something called a SHA-256 hash function. And what that means is, no matter what input you put into it, it's going to give you a 256-bit output. When we talk about bits, if you think about it, a computer operates in a binary language. And the only way that it can sort of know or understand something is in terms of, on the circuit, is there electricity present or not present? If electricity is present, it refers to that as a 1. If electricity is not present, it refers to that as a 0. So what computers do is they receive information in terms of 1s and 0s. They then can convert those 1s and 0s into text, images, all sorts of things. In the case of a SHA-256 function, it's going to take these 256 1s and 0s, and it's going to convert that into what's referred to as a hexadecimal format. And what we mean by that is it's going to take those 1s and 0s and convert it into either A through F, right, or 0 through 9. So that the output that you get is going to be some string of A through F and 0 through 9 that, if represented in binary, would be 256 1s and 0s. And remember what we said about these things is they're asymmetrical, which means if I have the input, right, every time I put the input through it, I'm going to get the same output. Now, what if all I had was the output? I had 126. I can't reverse engineer what the input is, but if you give me the input and I know what the output is, right, and we plug this input into the hash generator and I get the 126, I'll know, aha, you know what? This is the correct key pair, right? This input equals that output. But I can't know that unless I have the output and somebody else gives me the input. Right? Now, and this is what we use basically to encrypt things, where we can take any data, run it through a SHA-256 algorithm. We'll essentially get this string of numbers and letters, which we've been referring to this as kind of the fingerprint. And so if I want to prove later that this document, this statement, this thing that I have is authentic, and I have I can produce, and you have the output, right? You have the fingerprint, and I give you this document, and you run it through the SHA 256 generator. When it comes out, and you see that your copy matches the copy that we just put in, then voila, we know that's authentic, right? Now, it is possible to fake the system if you can possibly guess the SHA 256 output, right? But that's going to be pretty hard to do. And so what this means is hashes are unique, right? Because there's so many different possibilities. One hash represents one specific input, and a hash will never represent two or more inputs. And then hashes generates a 256-bit output, which is basically enough to identify pretty much every single thing in the universe. It's a pretty big number. Hashes are asymmetrical. There's no inverse hash function. You can't reverse engineer it. The only way to basically break this would be to use brute force. And they're completely random. So there's no pattern. You make the slightest change to the input and the output is radically different. So it's unique. One hash represents one input, right? It's asymmetrical. It only goes from input to output and not ever the other way around. It's completely random. So let's see what this is, how this is all tied to blockchain. So we're going to talk a little bit about hashes, the Merkle tree, and mining. So that's going to be the next module.